Good morning friends, we are today starting again with trying to understand what's a t-test. As I told you, we will do some practical about t-test and its applications. Okay, now this is where we left off. Now this I already have told you, but I got a flow chart. I am just telling you what we have to do. So we will state a null hypothesis, okay, state a significance level of 1%, 5% or 10%. Okay, what does significance level means? How much error you are ready to tolerate, that's it. 1% error, 5% error, 10. What type of error? Type 1 error. What is type 1 error? Rejecting the null hypothesis when it is true. Okay, that's one thing. Decide a statistical test, okay, t-test, z-test, f-test, that we have decided, we have talked about it. Z-test is more than 30, t-test is less than 30, and we have f-test, which is for a ratio. Okay, now if you take t-test for more than 30, it will definitely work. If you take z-test for less than 30, it will not work. So t-test is the safer side, therefore most of the people know t-test, not z-test. Okay, calculate the value of statistic, that we did. Okay, then compare to t critical, we did talk about the confidence level. Okay, and we will talk about it again today. Okay, and calculate the critical value. Okay, and this way, in this, that the modulus is just compared with the statistics, not the value, and then on that basis we reject or accept. Now let's go back. We discussed this example. Now we will use R to demonstrate this. Okay, so we go for R console. Now we will define a variable called x, which will be, let us take these values. Okay, slideshow, yeah, so which will be this. Okay, just a second, my data space, there is some error in the code editor. I am rerunning the okay. So what we are doing right now, we are defining a vector of integers. We have talked about this in the basic to R course. Okay, now see, if you type x, these are the value which will come. Now we have to do a test on this. Now what is our question? Our question is this sample, okay, a certain breed of dogs, is around 25 kgs or not, the mean. So now what we do? Now we, please pay heed here, we go for teaching, then we go for parametric test, then we go for test of means, then we go for one population. Okay, now here we select x, and here is what we will enter, 25. This is what we are checking. Okay, it is a two-sided test and we submit it. Now please see here what happens. It says the estimated mean is 25.1667. In our case we got this 25.167 is 25.17. Okay, then it calculates the standard deviation. Now we told you that the standard deviation, here please see, the standard deviation is obtained by finding the corrected mean. So please see, there are two sort of standard deviation. Let us check this here. Okay, so we will make a, for using standard deviation function we need to use data frame. Okay, as data frame, why I am doing this? Because x will not be accepted by the package descriptive stat. Now we go to descriptive statistics, we go for this Okay, now please understand, we are calculating corrected variance and variance. You see 5.47, 5.96. Now the variance and corrected variance are two different things. When we just divide by n, it is called corrected simple variance, and we divide by n minus 1, it is called corrected variance. So we have got corrected variance 5.9697. Please see here, this is what we got, 5.97. Okay. Now standard deviation obviously is got. Now we see we are getting the t statistics at 0.24. Standard error is found, t statistics is found, t statistics is this 0.24. Let us check what is the value for ours, 0.362997, which is ultimately 0.24. Okay. Now having said these two things, now what we said, statistically we will calculate at the value of alpha, the critical value of t. Okay. Now we will write some function and tell you how to do that, but main thing is, please see, when you are doing on paper, you have to calculate t critical or find t critical from the table and then say at this value what is the function, what is the relative weightage. So if the t critical is more than t statistics, please pay heed here again, I am using X journal right now. If this is t critical, if t statistics lie here, then we reject. If it is lies here, we accept. Please see the flow chart. Now this is written other way around, t critical less than t statistics. Okay, simple. T critical less than t statistic and t critical more than. Okay. So this is what we do. Now when you are doing a computer based test, you per se do not need to find t critical. Okay. On a computer based test, you get the value p value. So what it is trying the other way, the critical value for test t study 0.23 is, if 0.23, the level of significance is 0.8, not point. So at 0.05, the critical value is 2.201. Okay. So obviously it is, the critical value is less, the critical value is more than the calculated value, hence the hypothesis will be accepted. Okay. So the hypothesis is accepted. Now what does we do here? Instead of finding the t critical and t statistic comparison, we directly look at p value. If the p value is less than 0.05. Now please see, here the things go different. This is for t stat, reject H naught, accept H naught. Now when we go for critical value, if p is less than 0.05, we reject. Now please understand, the logic is similar. This is 0.05, this complete area is 0.05. This complete area is 0.05 maximum. Now if our p value lies here, we will reject the null hypothesis, and if the p value is lying here, it will be less than 0.05. Okay. So here again we will check the p value. The p value is 0.817 and you will hear it in many videos. आप बहुत सारे videos में सुनेंगे p value 0.05 से कम है, p value 0.05 से कम है. So On computers, we calculate the p-value. On paper, we calculate statistic value, and we find a statistical value from the table. Okay. So here the p-value is 0.817, which means it is lying here somewhere. Okay. This is this area. Please understand. P-value is always this area. This is 0.817. It is lying on the left. Hence, we accept H naught. That means the mean is equal to 25. Okay. And as you can see in the confidence interval, the interval 25 is coming. The confidence interval, the interval 25 is coming. Hence, we say that we could have seen multiple things. Either we could have seen p values, or we can see confidence other values. Okay, let us do this experiment again. Let's take this another way. Okay, let's rerun this. Let's run again. Okay, sorry. Let's run it again, and we say 22. Okay. And let's find the value again. Now please see, the moment we wrote 22, the p-value is comparing, because it is comparing with that x minus mu. Okay, the statistic value change, the t statistic change from 4 point. Now it is come at 0.0091, which means this is much less than 0.005. Hence, we have to reject h naught. What is h naught? H naught is the value is equivalent to 22 in this case, because please see here, यहाँ पे हमने लिखा हुआ है null hypothesis mean is equal to 22. Now the mean is not 22. Simple. Okay. You can also see that 22 is not coming in the confidence interval. So we have shown you both things, that how do you test a particular mean value of a sample, and we have also shown you on pen and paper how do we calculate this. All these steps are taken, finally the findings are same. If it is 25 as the mean we are testing, we say the mean is equivalent to 25. If we are studying 22, 28, then the readings are different. Okay, and you can keep on checking this. Now see here one thing. If I say this range is same, okay, this range is same, please understand. Either I test the mean as 25 or 22, this range is same, 23.614 and 20. Why? Because the sample has a mean. This is sample mean. One time we are checking that if the population mean is 25 or the population mean is 22. Okay. So we are checking the population mean. Okay. Now what does sample mean doing? Sample mean is trying to tell us, when we take off confidence interval, if this is my sample mean, this is the region of 95%. Okay. So 95%. Therefore, our value which is coming, let's check it here, 23.61, here 26.71, and here we are getting 25.16. Okay. Now this can be easily checked by, if you remember, let's go back and show you this thing. X bar minus, x bar is 25, sorry, 2.5, 25.16, T alpha by 2 is 0.025 because alpha is 5, then 9 minus 1, oh sorry, 12 minus 1, and s by root n, we have all these things. Similarly, please check here what I was trying to tell, irrespective of the population mean you are checking, if the confidence interval is same, the range will be same. Now we check another time. Okay, another thing here. Here we go and we say, okay, please check for 90% of the data. Okay, and the range should see, the range is decreased. So, if this is 95%, this is 90%. Okay. So, in this way, same thing here, please check. If I increase my range, I will run again this one and I will say confidence interval of 0.99, not 90, but 99, not 0.95. The confidence interval is that interval. Now, what let us see is the range 22.97 and 27.35. Can you see this? 22.97. %. Okay. So, this way you have to understand how does the confidence level changes and how does the mean of the population is checked, and this is called one sample t test. Please understand, now we are going in more depth of t test today itself, and then we will go to ANOVA also, which is advanced level of t test, we will discuss later. Now, please come here again back, come here, and we will talk about something different. This is a command which will tell you if you want to know the t table, if you want to use the t table. Okay, let us use this. Qt 0.025 and degree of freedom 11. See, we have got, please understand, we have got this thing as 2.5% and here this has 2.5%. So, this is Qt 0.00025 into df, and can anybody tell me what is this? This will be 95 plus. Okay. This is 1 minus 0.00025 df. Why? Because this complete area is 1, okay, and we are reducing this. So, now let us check it out in our console. Now, we type here 1 minus, see. So, there was one was t negative, t positive. So, by all calculations we have understood how to get the t value also using R. Okay. So, t value through table, t value through R, if you want to calculate that way. Now, this is very important. There are three types of t test: one sample t test, which we have discussed. Thus, there are two sample t test independent samples, okay, and then there is a paired sample which is called dependent sample. This difference is what we have to understand a lot. Okay. Two sample t test are of two categories: independent sample and paired or dependent sample. Okay. Now, please understand what does it mean. This is where we have to understand things. I will again go to my board. Suppose this is a data. of, let's say, score. And this is some other parameter called grouping variable. Okay. So we have scores 1, 2, 1, 3, 5, 6, dot, 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 and group could be 1, 2. Whoa. Please understand, t-test only works at 2 levels or 2 level of group. When we increase the level of groups, it becomes an ANOVA. 3, 4, 5, sorry, I am wrong here. There are only 2 groups, 1, 2, 2, 2, 1, whatever be the distribution. In such comparison, it is assumed that the respondent this and this are different. Okay. This respondent is R1 and this is R2. Obviously, it has to be. Like if I say the city marks affect your percentage, so city marks my city affects my percentage, another cities affects another percentage. So we both are to different response. On the other hand, there are sometimes like test. Before attending the class, my mathematics score was 10 out of 20. After attending the class, did my score improve or not? So I am the same subject. The same subject is given different treatments or different tests, or I am being taught maths by teacher 1, then I have been taught by teacher 2, then we will see how the scores differ. Okay. If we have same subject, then we have data like this: population score of population 1 or group 1 or score of group 2 or treatment 2. Please understand, this grouping is not actually the grouping, this is actually a condition. So you have to say treatment 1, treatment 2. Why I wrote group? Because this is what the common parlance talk about. Treatment 2. Okay. Now here same respondent is giving two responses, okay, or two calculations. Okay. So this is dependent sample because the samples are linked, both samples are linked, samples of this, and this is independent sample. Okay, and we will see demonstration of this right now. So let us import our data, import our format file which we have in the download folders. That's what I assume, school 1. Okay, submit. We have talked about it multiple times. This is our data. Now we are trying to say there are categories. Please understand. Let's see the category age, or let's see the gender category. Yeah, gender 1 1 1 0 1 0 1 0 1 0 1 0 1 0. Okay, so there are two categories. Now these are factors. So we make it factor. Okay, and you see, because why factor? Because 1 and 2 are numbers, not names, not okay. Now we go here and we go to parametric test, we go for means, and we go for comparing means for two independent samples. Please see the word. And we are comparing it to gender Just a second. I think this factorization create a problem. We are writing 1 2 1 2. Ideally we should write, okay, let's take H. H 3 group, means of 2 paired independent. Okay, now so we have comparing the means of CSC underscore 1. We can take JP1 also, not an issue. According to H2 category, which is having 2 levels, 1 and 2, which is coming here. Now comparing populations. So I am comparing 1 with 2 or 2 with 1. That is important, and we will see how, because the ordering is important. The test. Okay. Now we press submit. Now you see population 1 and 2. Now population 1 is not dash 1, it is the first one. Okay. So we assume the first one is first. If we were reverse it, otherwise it could have been different. So there are 2 populations. How? The complete data is, if you see, around 590, we have reduced 590, then okay, the degrees of freedom are, so 5 out of 590 we will see this. So we can see this here how. We will see here by means descriptive means parameters. No, in just a second. We will starts. Sorry. So we will have this plot by groups. Okay. So these are the means of group 1 and group 2. Now again let's do it. This was the graph, and let's see the quality of the descriptive statistics. CS1 statistics by group H. Okay, mean. Where is the mean word? Mean, arithmetic mean. Okay. Okay, please see here, this is a problem. This is what happens. Gender should work. Okay, editor, please remove this. So what we are trying to say is 309 entries are there and 279 entries are there, and these two are differently differently affecting or not affecting. Now first test is comparing the means. If you remember, we did discuss there are 3 conditions. It has to be normally distributed, okay, and the sample variations should be equal, okay, or obviously independent sample, the samplers variance should be equal. Now that is what is the assumptions being checked here. So again, so as the p value is 0.19, please see here, as the p value is 0.19, the hypothesis is of F test is of comparing variance that the 2 variants are equal. Now the p value is less than more than 0.05, which means we fail to reject the null hypothesis, we accept the null hypothesis, we assume they are same. Hence we say that they are of equal variance, and hence we are testing it here. So now the p value come at 0.008, which actually means that at 0.05 level the difference does not exist. At 0.10 level the difference exists. Okay. Why did I say that? Because the p value is 0.891. See, p value is 891, confidence level is 95. Now does this interval contain 0? The confidence interval which we are talking about is minus 0.1 272001. So there is 0 in between. So at 95%, we say they are same, because 0 is contained, the null hypothesis value mu minus u2. What is the hypothesis, what is the null hypothesis of independent sample test? That mu1 minus mu2 is equal to 0, and that we can check here also. See, mean of this is this, or mu1 minus mu2 is equal to 0. Okay. Hence, we find out. Now, at 95% we are saying they are same. Now, what happened 90%? Let us run it again. Now, you see at 90% what is happening, the range has changed. What has it become? Minus 0.249 to minus 0.004. This does not contain 0, 0 is here. Hence, they are different at 90% confidence. As you can see, at one point we say they are same, but 95%, and another point we are saying they are different at 90%. Okay. So, this percentage level will change your answer, as in the previous case where we were trying to say mean of 23, 22 we were testing. Okay. So, please understand this. Now, this is very important, please pay heed here. This F test for comparing means is very important, because after the means, generally we assume the means are equal. So, we want the test to fail or p value to be more than 0.05. If they are unequal, then we go for the first table. Okay. We go for the first table. Now, please see, if you remember, we will explain this to you, that how all these values comes as what is degree of freedom and what is F statistics. This we will explain in the ANOVA class, okay, that how to get an F table, F value. So, sum of square, two groups are there, sum of square and everything, we will do that SS, sum of squares of errors, okay, total, within group, between group, everything we will do. So, please understand, when you just have to compare two tests, two variables, sorry, one variable with two groups, then you go for an independent sample. Now, you have looked at here, okay. Now, we will go for another test called the paired sample t-test. Now, why it is called paired sample t-test? As I told you, one sample, one respondent is active in both the readings in the pair, okay. Now, please see here, how do we have to either create the data or we have to load a data. So, let us create a data. So, as we told you, there are two levels only, score of group 1 treatment 1, I have placed the scroll log somewhere, yeah, and treatment 2, okay. So, let us say treatment 1 I get value of 3, 2, 3, 4, 5, 1, okay, and in treatment 2 I got 2.2, 2.8, 4.1, 4.9 and let us say 2, okay. So, this is our data. We have taken 5 respondents. 5 respondents responded to treatment 1 and treatment 2, or test 1, test 2, whatever you want to say, condition 1, condition 2, and we have got the data. Okay. Let us save it. Okay, now we will import it. Let us see if the import happens. Let us cancel this out. Let's cancel this out. We will import the data from this. Okay. And now this is what we have to go, t-test pair data. Again, see, please see, if the preview does not come, that means there is some issue with the file. Okay, let us try again. The file has some issues, no problem. We copy this file. Okay. See what was happening? There was a overlap of the variable name. Hence, the object was, because we already have created my csv.data. So, now we can read the earlier file also. This is t-test paired. Okay, numeric, submit. Now, this will be created in a separate tab. See here, workspace, my csv.dat. .dat is the file. Okay, now here we go, and we go for parametric test, we go for means, and we go for paired population, compare treatment 1 with treatment 2, and let us say they are equal, or whatever it is. Okay. See, here also again you see that 0 is contained, okay, hence they are not different, or the p values more than 0.05, hence they are not different. Because now let us check what happens if we run it again. Let us say at 65%, what happens? 0.65. See, at 65 also it is still containing 0, but as we decrease it, it will change. Let us say 45%. See, 40%, the confidence interval is, is very similar. Let us check it again, what has happened here, why it will become 0.5. Yeah. Now you see, 0 is not in between. Okay. 0 is not yet between. Now, we do not have to compare the p value with 0.05, but we have to compare with 0.5, and at 0.5 it is less than 0.399, it is 0.399 is less than 0.5. 0.05 is for the confidence interval of confidence level of 95%. We are 50% sure that they are different, and I hope I will be always very frank with you. This should work at 60% also. See, the p value, as I told you, the p value will not change, the statistic will not change. It is your benchmark which is changing. So the change is happening on the rightmost columns. So here I by mistake I entered 0, here I entered 50. So okay, 0.4 is the error, 0.4 is the error, not 6. Okay, 0.4, so 0.399. You can check it. If I say 65, when I did 65, it included 0. So we are 60 to 62% sure that this is a okay. Or very simple thing is take the p value, subtract it from 1, that much sure you are. P value is minus 1.39167, so you say okay, I will take the value of let us say 0.61%. Okay. So 1 minus p value, whatever p value it is coming, is actually your confidence level, the data is speaking. Now for you to accept or reject, you have to check your significance level. So p value is the probability of error of type 1. Okay. So the probability will not change. Your benchmark of accepting that level or not will change. The cutoff will change, not the marks. So confidence interval is the cutoff level we decide. So at 1.4, okay, around 0.6 difference or 0.4 error, we can say these are different, but at 95 we cannot say that. At 95 we cannot say it. So these are the two tests primarily are very important. These are 3 tests we have discussed today. Okay. So t test, now please see the observation which we are trying to say. Okay. In paired t test, each sample minus 2, because n minus 1 is group 1, n minus 2 is group 2, combine both of them, that is n minus 2. Now there is only one sample here because actually it's one sample, so n minus 1. Okay. What is n? N is number of one respondent, not the complete entries. Okay. It is n minus 1. So n here is 5, so it is 4. Okay. So now as you can see the examples here, there is nothing to elaborate, but things are very similar. Mean difference in heart rate of a group before and after exercise. So treatment 1, treatment 2. Treatment 1 is no exercise, treatment 2 is some exercise. Okay. Mean heart rates of 2 groups. So this is very important. As I told you, subjects might differ. Subjects are differing. Okay. On that base, we have 2 sample tests, same thing. Okay. Now, if you see, we clicked here something called parametric test, and I wanted to touch that also. Parametric tests and non-parametric tests are different. So there are some assumptions of parametric test. Okay. That first of all, a dependent variable is scalar or ratio. Okay. Now what does it mean? Dependent variable, the y which we are always analysis of variance, we will go talk tomorrow or later, or we have talked about the dependent variable in the t test. That is again what we say a number. Okay. So if it's a number, not number as a name, number as a scalar data. Okay, scalar or interval, then we call it as a interval or ratio data. If the dependent variable is nominal or ordinal, we take a non-parametric test. Okay. There is no randomization. If you have properly selected them, then it is again a chi-square test. It is not a, it's again a non-parametric test, not a parametric test, because randomization is very important. What does randomization mean? If you remember, we discussed the technique of sampling. So that is one thing. You are not having a predefined logic that let's take these 3, then these 3, then these 3. Okay, that is not randomization. Okay. And the shape of in population of interest approximately normal, we will discuss more about this normality test when we are trying to talk about the regression coefficients. Okay. Now, so please understand here, we have more or less discussed things. There are some things which we will discuss about test, which we will talk about later. I will just introduce the terms because now we are going into analysis. Tomorrow, after some time, we will cover ANOVA. Now what we are trying to do, हम लोग क्या करने की कोशिश कर रहे हैं? What we are trying to do? We are trying to understand the application of test. Now, generally, just p value is asked. Okay, and if the p value is less than 0.05, you say we reject it. Otherwise, Please see, having statistical difference does not mean the difference is large, but difference is there. So 19.1 and 19.01 are different, so that 19.02. But is the 19.01 and 19.02 different? Please understand, people do this mistake. They try to call this as significant. There is no significant difference. No. Significant difference is not about the size of effect. Okay? It is about the population thing, that is it different or not. Now, the effect size is trying to measure the actual difference, how much is the difference. If two samples are saying, okay, math scores of girls and boys are different in state A and state B, and we get that there are difference, we do the t-test, we get a difference. Now, what does it mean? How much is the difference? We cannot say that. We cannot say that. Okay? For that, we have to go for effect size, and we will talk about this later, because gradually smaller steps will be taken. We will cover this. Okay? And similarly, this, what is the power of test? This is 1 minus type 2 error. Okay? So, now this is very important for us to understand. We also have to understand why one tail test and two tail tests are important. As you do remember that we try to understand, let us show you. This is a two tail test where you are interested in finding the values. It is one tail test because the two tail test, because it is both directional, bidirectional, and where the alternate hypothesis, they are not equal. But if the hypothesis is it is less than or equal to, please see that, that is what we have. Please check it here. Let us check it here. Yeah. Test option. This will call a different story. Okay. This will talk a different story. See, just by changing the options, I get different result. Okay. So, minus 2 to infinity, that was one thing. The moment I said it is bidirectional, it is different, and if I make it otherwise, see, at one point it is this. So, minus 2 is here also. Okay. Minus 2 is here also, minus 0.3 is here also, minus 0.3 is here also. Okay. Minus 0.3439. So, in that way, this is very important. One tail test, two tail test. So, if it is just 95%, this one 95%, if you are testing this side only, then we have only 5%. If you are testing this side to be 5%, then we are getting 95% for the t statistic. Okay. T critical levels. Please see the t statistic value is same in all cases. As I told you, if you change your confidence, things will change like this. Okay. So, with that we end today, and now we will discuss ANOVA next class. Thank you very much.